Okay, good morning once again. So in our previous class, we tried to understand classes in depth. We tried to understand constructors, this keyword, instance methods, static methods, and other things. So today, we will try to understand dependency injection, and we'll try to go in depth. And the reason why is because Nest.js heavily rely on dependency injection. And that is a framework we're using to build server-side application in this bootcamp. So if you don't understand dependency injection, you will just be doing what you don't even know. You will just be, let's say, building applications with Nest.js blindly. So it's a good idea to get a grasp of the building blocks before we get to the main thing. So what is it about dependency injection that we want to understand or want to know? So objectives for today is to introduce dependency injection. We'll understand the basic concepts, understand what dependency injection is all about, and what we can use it to achieve. We will also build dependency injection containers, and we'll see the reason why we need containers as well. So also learn how to test basic dependency injection applications. And we'll see how easy it is to test them with containers as well. So moving on, introduction is the first thing on our list. And the first item under introduction is what is dependency injection? So I guess some of us have not heard this before, dependency injection before. This is our first time. I want to understand what it is. So dependency injection, in short, you can just call it DI. It's a design pattern that implements inversion of control, IOC in short. That is inversion of control for resolving dependencies. That is, instead of a class creating its own dependencies, they are provided. That is, provided means they are injected. So instead of a class creating its own dependencies, they are injected from the outside. So that is basically what dependency injection is. It's actually a design pattern that implements inversion of concern for resolving dependencies. So why do we even need dependency injection? So a second, please. So why do we need dependency injection? Why we can just do things the way we want and without even stressing ourselves and all of that? Okay, so the problem is tight coupling. Okay, so we should just quickly take a look at an example of tight coupling and how dependency injection is here to solve our problem, and it has solved it already. But since we are new to it, let's say it's here to solve our problem. So tight coupling is where you don't inject dependencies. Instead, you just pass them, should I say, couple them directly in the class in which they are to be used. So in order to, let's say, demonstrate that, we just have to see what tight coupling is and how dependency injection is actually the solution to this problem we're discussing. Okay, so let's say, for instance, we have a class email service. Okay, close all files. Let me zoom in like this. This is okay. So let's see. First, it's the index. So we've created a file of index.js. So right now, let's see what the problem is so we can solve it actually. Let's assume we have a class, or let's say we have a class of class email service. In this service, we have a method that actually sends email. So we say send, here is the method. It will take two subjects and body. So this method sends email. Simply what we'll do is we'll say we just log sending email to two. We will say subject like this. Okay, so I guess this link type like this. So this is our email service with a single method for sending emails actually. So we have another class. They will call this one user service. So what this service would it will have, this one will take a constructor. It has a constructor actually. This constructor has no parameters. And now we will register, let's say we register this service here. This dot email is equal to new email service, something like this. So this is actually tightly coupled. We don't want anytime, just imagine you want to change the email service to another one. So you have to like come and then try to remove this. That is not, what if your code is in production? Something like that. So we'll add a method to this. Let's say register user. This one here will take user data. So it will register the user and send an email. So we'll say log or registering user. Say user data, email like this. And then we say this one here registers a user, but we need the email service to actually send email. So we say this email service would send, and this send actually takes in three things, three arguments. That is a to, subject, and body. So the first one is to, that is a user data email. The second one is, oh, the second one is the subject. Say welcome. Should we say welcome? Okay, welcome. And the third one is um the third one is the body. So we just pass in the body of thanks for registering like this. So we can now go ahead and use our service. So you see const user service is equal to new user service. And then we want to register a user, say user service dot register user. So in here we pass in the user data of email, passing john@doe.com like this. So what we'll go ahead and run these files. Node index.js. We have registering user johndoe.com and sending email to john@doe.com. So we are using, this one is the user service, and we're bringing in another service, which is the email service to send emails. So let's say this is a service provider, the email service. Let's say it's Resend, or it's Magon, or something like Kit, formerly known as Combat Kit. So we're bringing it in to send emails, but as you can see, this here is tightly coupled. So I imagine we have a ton of services here, like 20, 30, or 50. We don't have to do this. So that's where dependency injection comes in. So with dependency injection, how can we go about this? Okay, well, first of all, come over here. We'll remove, we pass in the email service as a parameter to the constructor. You say email service. You say this email service is equal to email service, like this. Instead of coupling that service in the constructor, we just pass it as a parameter, and then we initialize it here. So out here, what we will do is we will just come over and then do something like const email service is equal to new email service, like this. They will pass in the email service to our user service. And now we can go ahead and run our file once more. And we have registering user John doe.com and sending email to john@doe.com. So now if you want to change your email service, you just come over here, then assign this to a new email service and pass in. It's already passed. Just change this to something else. Say Kit mail service or anything. But as you can see, this is not as tight as what we did earlier. What we did earlier was not passing it as a parameter to the constructor, or just initializing it directly in this class. So what we will do now is we've seen the problem and we've seen how we can solve the problem. But this is just a basic example. So we have to move on to something that will make sense to you, because I believe right now it's not really making sense. Then we have types of DI, that is types of dependency injections, which are constructor injection, which is most common. I guess the one you just saw me do now, that is constructor injection. We have setter injection and we have interface injection. And this one is less common in JavaScript because JavaScript is not 100% object oriented. Let's say it's a kind of 50% functional and 50% object oriented, or less, or more or less, something like that. So we have constructor injection, we have setter injection, and we have interface injection. And moving on, we have the benefits of dependency injection. So what are the benefits of dependency injection? 1 is testability, 2, flexibility, 3, loose coupling, 4, single responsibility and configuration. So for testability, dependency injections are easy to mock. The dependencies are easy to mock. And flexibility, easy to swap implementation, like what we did. If you want to sweep and swap the implementation here, all you need to do is just come over here, do away with this, then add something else, or just come over here and do something. It's easy instead of tightly coupling it inside of this class. And over here we have loose coupling. Classes don't need to know about concrete implementations. Okay, so what's here is, this is fantastic, because the user service doesn't even need to know the implementation details of the email service. Just pass it as an instance and an argument to this user service, and user service will take care of the rest because it's actually using it here. That is sweet. It actually knows that this service has a send method that takes in this argument, but it doesn't know what the send method is doing behind the scene or what the email service is doing. Its work is to just call it here and make use of it. Okay. So the next benefit is single responsibility. So class focus on their core on your core logic. So we don't this doesn't even need to worry about this one. It just need to focus on its core logic. Just call it here as parameter, initialize it. Come over here, register a user, and call this service to send email. That's it. You don't need to worry about any other thing. And configuration. Dependencies can be configured externally. So over here, instead of doing what we did, configuring dependencies internally, we configure it externally and create an instance and pass it to this user service here, and we're good to go. Okay, so now that we've introduced dependency injection, I can say we are still confused about everything because this is a kind of an advanced concept. And you don't really need to know in-depth dependency injection before using Nest.js. But what I love to do is, before we continue, let me just say this. We have a ton of developers using tools they know nothing about. And sometimes as a software developer, I sit back and I imagine, how can we be using tools we know nothing about? Like tools we don't even know how to use. Okay, because you are building stuff and there's a library to use. You don't even know how that library works, the size, or let's see how the impact it will have on the application you're building. Then you jump in because it's a library. You jump in, grab it, and start using it. So I can't say for backend developers, but as a React developer, there's this thing that people jump in and they feel React is basic and is the best JavaScript library or framework they will start with. But that is not right. I guess you need to React is a library actually. So if you want to start building front-end applications very easily, React is very, very powerful. But the mistake people make is to jump and start learning React, and they learn it in a couple of months, 3 to 4 months, and they want to build applications. And I look at it and say, oh, because what that library is doing under the hood is very powerful beyond imagination. And some people don't even know. They just do it, use effect, use that, all of that, and they do it. But sometimes I see code people write. So I see code people write and I say, wow, so this is actually a developer's code. So a short story, a couple of months back, I had to work with a company, and the company I was working with, there's this developer that was reviewing my code. You assign tasks to me and I also review my code. And funny enough, I was more experienced than the person that was reviewing my code. So after writing code, he will review it and ask me questions, simple questions that a beginner is supposed to know. You are reviewing my code and you are asking me questions. Things you are even supposed to correct me. You are asking me, you don't know. Or you are reviewing my code and they want to explain it to you. And I was like, wow. To cut the long story short, I things happened and I left. So before you use any framework or library or you do anything, at least have a basic understanding of the technology or a basic understanding of what that tool is doing behind the scene so that you can easily debug or catch mistakes easily. It's easy that way. So we have a ton of libraries or frameworks out there. We have Fastify, we have Honor.js, we have Express.js, we have Nest.js. And some people will tell you they love using Nest.js. Some will tell you they love using Express.js. Some will say, Honor is my favorite. I'm not going to say which one is my favorite. But before you choose any framework or any library out there, just be sure of what you want to do with it. Or you got hired by a company and they're using this one. Okay, since you are working with them at that moment, just put in your best and try to understand what that library or framework is doing so you can give them your best. Because what is worth doing is worth doing well. And if you can't do it well, just don't do it. You understand? You don't have to write code that will cost companies millions, put them into technical debt and all of that. So we should just know what you're doing. Just know what you're doing. know where to use reduce, know where to use map, know where to use JavaScript function, know which JavaScript higher order functions are mutate data and which ones doesn't mutate data, and all of that. So just know what to do. Make sure you know what to do. Make sure you have a mentor, an expert that you are following, that you can always guide you, or someone you show what you're doing that will always put you through, something like that. Don't just do things blindly. So it's just a piece of advice. Okay, so moving on, we will build a simple um, dependency injection container. So your question will be, why do we need a dependency injection container while we can just um, configure services and pass them as arguments to a class or something like that? Okay, so the reason why we need a DI container is manual dependency injection actually works. As we've seen, we've tested, we've done it, and it works. But it becomes cumbersome as applications grow. So imagine you want to build an enterprise application with Nest.js. So an application with about 200 endpoints or about 300 endpoints, API endpoints or something like that. And an application that is serving a ton of users. Uh, Even if it will be replicated and have about 10 different instances across the world, CDNs and all of that. But the best optimization is, first of all, know what you're building, know what you're doing, write good code. That is where optimization starts, because scaling servers, horizontal and vertical scaling and all of that doesn't matter. It all starts with your code and how your app works. So all those will come out of the box, but this will help. So the reason why we need DI containers is to automate the process of creating and writing dependencies. So you don't have to do that manually. Every time you create dependencies manually and then you write all of that manual. No, no, no. So the reason why we need DI container is to automate the process. It's just automation of automating the process of creating and writing dependencies. So you'll be asking, are we not already automating it in this way? I don't think so. That's just a manual way of doing it. But we'll see it in just a short while. So what we're going to be doing here is to write a simple DI container, actually. So let me just come over here and comment out this email service is equal to new email service, like this. Great. So now create another file of dir container.js. So let's move into this file. Clear our terminal, get ready to move. So we have dir container.js file here. I want to build a simple dir container. So the name of this container will be dir container. We have class dir container. And inside of this dir container class, we have a constructor. And this constructor takes no parameters. Inside of this constructor body, we initialize two, storage systems. We have one for storing services and two for storing singletons. Okay, so before I move on, let me just write singleton like this. And let me quickly explain it before we move on, because some of us don't know what a singleton is. So a singleton is a design pattern that restricts a class to only one instance and provides global access to that instance throughout your application. So for instance, now this DI container, you don't want it to be called more than, you don't want to have something like this. So you already know what an instance is. We have instance 1 is equal to new DI container. And we have instance 2 is equal to new DI. You don't want this. You don't want a situation where different instances are created. You just want to have a single instance that is shared in your application. So let's say, for instance, you are running an application, a server-side application, and there's a service you need to create. Even let's take a development server, for instance. So you have this service, you create this instance, and anytime you stop your development server and start it, a new instance is created, and that other instance is not destroyed. So that will cause bugs in your application. But we don't have to go deeper into that. Just know that a singleton is a design pattern. So this design pattern, it actually restricts a class to only one instance, and it provides global access um, to that instance throughout your application. So we need two, this thing here, two storage method. We have one for services, which is equal to a new map. And we have two for singletons, which is also equal to a new map. Okay, so sorry, we forgot to talk about map the other time. But in this case, what we'll do is we'll just keep it, use map, and later on, we'll discuss what maps are. And after discussing what maps are, you come back to this and you understand the reason why we're using maps. So now that we have this, we have a register method. So what this method does, it registers it registers a service with its dependencies. So we have register that takes in a name, factory, and dependencies like this. So right now, what are we doing? Okay, dependencies is an array. So let's default it to an empty array. So you can recall about default parameters. So dependencies don't have to be undefined. It should always be an empty array if nothing is passed to this register method. So what we need to do here, we need to register this service. So how do we register this service? You see these services dot set. You know, a map has a set method. So we want to set, it takes a key and a value. So we want to set the name. We want to use the name of the service. We want to set the rest of the things. Factory, dependencies. And we say, is it a singleton? We say false. It is not, like this. So this is the register method. I'll get to understand what this method is doing. So this one registers services. So we write another method that registers singletons. So register singleton like this. Singleton like this. So this one will also take a name, factory, and dependencies that would default to an empty array. So this, let's just copy this here, bring it over. But this time around, we say true because it is a singleton. Okay, so now that we have these two methods, we need to have a resolve method as well. So this resolve method, it resolves a service and its dependencies. And we'll see all of this in action soon because now you don't really understand what's going on. So we have resolve. Resolve takes a name. So that is the name of a service. So we see const service config is equal to this services dot get name. Remember that we've registered a couple of services here, and the key is the name. So if we want to grab a service, we use the name to get the service from these services here. This is basically our storage here. So we're storing services in this map. So we're using the name to grab those services. So we grab a service, and if there is no service, if service config, what we do is throw a new error. And this error we say, let's say service name is not found. That is the service. Let's say if the service is email service, say service, email service is not found, something like that. So what if it is found and it is a singleton? So if it's found and it's a singleton, or let's say if it is found and it's actually a singleton, so we say if service config dot singleton, and we want to check if it is singleton and it's already created, because we just want to have a single instance of a singleton. A singleton is, we just want to have a single instance. That's why it's called a singleton. We don't want to have two or more instances, just a single instance. So we want to check if it's a singleton and these singletons in the service dot has, if it has the singleton, these are map methods. The get, set, get, and has are map methods. So set is actually adding an item to the map. Get is retrieving an item from the map, and has is checking if the map has an item in it. So in here, if it's already created, then we need a single instance. We don't want to create another one. We'll say return these singletons dot get name. So this is to ensure that we just have a single instance of it if it's a singleton, because if it's already created, we check, is it a singleton? Because the singleton here is true. If it will return true. And does this singleton storage here, does this one has it in the map? If it returns true, then what we need to do is to grab it from there. We don't need to create another one. But if it doesn't have, then what we will do is we come over here. Below, we see const dependencies is equal to service config dot dependencies. And then dependency is an array. So we want to call the array, we say dot map dependency. And then we say this dot resolve dependency. Okay, so things are beginning to get messy right here. Okay, so before we continue, let me show you something very quick. We have a rec.js, then we have function number that takes in n. And we say if n is less than or equal to 1, return n. Return else. Return n minus 1. Okay, so I just decided to do this real quick. Let's see if it works. Num 10. See node rec.js. Okay, if n is less than or equal to 1 return, else return. Okay, so we see n is equal to n minus 1. I just needed to come up with a simple example to show, okay, calling node 10. Oh, I just need to write a simple recursive function. Okay. So what do we need to do it? And we say, let's, okay. Let n equal to, n times 2. Return, say m. Return m. So this, I guess, okay. Maximum cost, okay. Let's see if n is exactly equal to 1. Maximum cost tag exceed. Okay, so what's happening there?
Okay. So what are you trying to write?
Okay, I'm coming, please. Let me just, I guess, I just wanted to just show you something. It's just a recursive function. And if this doesn't work, we'll just move on because I'm not even in a state to, I just wanted to show you, okay, undefined. I will have 1. Log num n minus 1, 10. Okay.
Okay, like a sequence 10, 9, 8, 7, 6, 5, 4, right?
That should be it. I guess we should just leave it like that. I don't know what's wrong with me actually. Okay, but what I wanted to explain is we have the resolve function here. And there's also a resolve function here. A resolve method here. And we're using this method here. And the reason why is because what we are doing is resolving the dependencies. So we passed in the name, we grabbed the service from the storage, we resolved its dependencies. So in the process of resolving the its dependencies, we encounter other dependencies inside of that service. So we also need to resolve those dependencies as well. So right there, we are calling this method here. We're still calling the resolve method to resolve it recursively. So for those of you who don't know about recursion, that was the reason why I was trying to just write a simple recurse. But I guess I should just come up with something simple. Let me just crack my head a bit. I think console log Fibonacci would be more. Okay, let's do, I guess, let's go with okay, let's say function factorial. Okay, which takes in n and then logs you know that the factorial of a number is the number multiplied by its let's say the factorial of 5 is 5 times 4 times 3 times 2 times 1. So we come inside this function. So we say if n, we check the base case, if n is equal to 0 or n is equal to 1, we just return 1 because the factorial of 1 is 1. Because 1 times 1 is 1 and 1 minus 1 is 0 times 0. That's not even possible because the factorial of 0 is also 1. Factorial 0 is equal to 1. Factorial 1 is equal to 1 as well. So we're not in a mathematics class and we don't have to prove this, or this is how it is. So if n is equal to 0 or n is equal to 1, we just return 1 because the factorial of 0 is 1 and the factorial of 1 is also 1. If not, what we want to do is we say return the number multiplied by the factorial of that number minus 1. So if we have, let's say we have 3 times, the factorial of 3 is 6 because 3 times 2 times 1 is 6. So if we have 3 here, we call the function, we skip this because this is false. And then it will come to this block. And then we say 3 times factorial of n minus 1. And n minus 1 now will give you 2 as an argument. So it will become 3 times 2. Then 3 times 2, this function will execute again. Now at that point, it will become 2 minus 1. It will return 3. The second time, it will return 2. And when it gets to 2 minus 1, it will become 1 as an argument. So it will execute this block instead of this one. So n is equal to 1, it will return 1. So let's try this out and see. Log factorial of 3. Let's try 3 first. Let's clear our terminal. Okay, so we are not, you can see log push just for testing purposes so we can see. Oh no. Okay, n minus 1. So we can actually log sorry. Okay. From one problem to another. Don't mind me, please. I don't know what's wrong. Okay, so but we've finally managed to come up with a simple recursive function to understand recursion. So we have the factorial, and the factorial of I'm not even writing it correctly. It's 2 factorial, not okay, 2 times 1, which is equal to 2. So this is 2 factorial, and 3 factorial is equal to 3 times 2 times 1, which is equal to 6. And 4 factorial is equal to 4 times 3 times 2 times 1, which is equal to 4 times 3 is 12 times 2 is 24 times 1 is still 24. So we have this. So we'll come over here, do away with this 0 factorial. We have 1 factorial like this. So if we change this to 4, we should expect 24 as our answer. So clear the terminal and then run this once more. So we have 24. So this is a recursive function. And if you try to understand recursion, just there's this advice I received from a mentor. He just said, you shouldn't understand recursion, just make it work. So just have a base case and have something you want that function to do. Have a base case. You must have a base case, but because by the time you do away with this, they will start having that error. Cost tag exceed, maximum cost tag size exceeded. So we don't have a base case. So the function will call itself, it will continue calling itself till it exceeds the maximum cost tag. So we want to, okay, now that we pass in 4, the first time it will run, it will return 4 times 3, 4 times 3, because here will be 3 and 4 minus 1, it will be 3. But 4 times 3 will give us 12. So this function will run once more. And when it runs again, n will become 3. And then we have 3 times 3 minus 1, which will give us 3 times 2 actually. But then we have 4. We already had 4, so it becomes 4 times 3 times 2. So 2 will run again, and 2 minus 1 will be 1. So the answer will be 4 times 3 times 2 times 1. So that is what is happening here. By the time this thing runs, it will try to, when it gets to this point, it will resolve the dependencies of this service. This is the current service. It will resolve its dependencies. So after resolving its dependencies, when it gets to the dependency, it will discover that, okay, this service has inner dependencies, so I will need to resolve those ones as well. So instead of writing another function to do that, we call this function recursively to resolve the inner dependencies. So this is kind of confused, but maybe it's confused to you, but that's how it is. At a point, you get frustrated with software there because there are a lot of things attached to it, but that's just the way it is. So you just need to figure out a way to understand this thing. We're calling this function recursively. But you'll be asking, how can a function call itself? And some of us, we already know this and it's normal. So if the service is a singleton, because after resolving the dependencies, we say const instance. So the factory, we create the service factory. This is what we call the service factory. So we'll create the service factory. So we'll say the service, const instance equal to service config dot factory. We pass in all the dependencies that we've resolved. See, dependencies like this. Now that we've created a factory, that is an instance of the service, that is the factory with all the dependencies, then we say if the service is a singleton, after doing all of this, if it's a singleton, we need to add it to the singleton storage. We need to add this to this storage. Set, not add, set name and instance. Okay, so this has been a long ride. So we should have a recap actually. This method here resolves a service. So first of all, we have storage for services and singletons. We will register a service. Then we grab the service name, factory, and dependencies. So we say we add this service to our storage. We set the service using the name as a key, and then we set the factory, the dependencies, and set if it's a singleton or not. But if it's a singleton, we set the singleton property to true. So now we'll resolve this service using the name because the name is actually the key. So if you want to resolve this, we grab the service by the name, and then you see these services get name. So by getting the name, we're grabbing this object here, this object as a value, we're grabbing it from the storage. So when we grab it, we see that it has a factory, it has dependencies, and have a singleton method and property actually. So when we grab this from the storage, if it's not there, we throw an error, throw a new error, service name is not found. But if it's there and it's a singleton, we just need to return it. If it's a singleton and it's already has been created, we just need to return it because we need to have just a single instance of that in our entire application. So, but if it's not, if it's a singleton and it has not been created, we proceed because this will return false. Actually, it's a singleton, but it is not found in the storage, so it hasn't been created. So we proceed. Then we grab the dependencies. So we'll grab the dependencies, we'll resolve the dependencies here. But when you call the resolve, we are calling this method here, we are still calling the method here because we are recursively resolving the dependencies and the inner dependencies of this service. So an instance is actually, we create the factory. Let's say the factory is the service with everything packaged. There's the dependencies packaged inside. So that is actually the service. Now we'll come over here and we'll check if it's a singleton and it has not been created, we'll create it. So now that we've created it, what next should we do? Return the instance. Wow, this is a lot. But do we really understand what's happening? I guess not. So let's proceed. After when we're done using this service, I guess some of us will understand. But for some of us who don't, I will still explain it, and maybe we ask questions where you're confused and we explain. But first of all, let's create services. So let's, for example, we have our email service. And inside of this service, we have the send method. And the send method takes two subjects and body of the email. So inside this, we say log which emoji should we use? The email emoji, email. This one. Yes. See, email sent to, and then we say that is the two. That's the email address. And we say subject like this. So this is the send method, and we are done with that method actually. So we have another service which is plus. Then we call this one logger service. What does this service do? It actually has a method that logs messages. Message. Then we say log. Let's see message. Message or an envelope. Let's use this one. Let's use this one actually. Log this so that we'll understand very well what's happening. The message, we'll log it to the console. Okay, so now we have another service, which is the user service. So this user service uses the email service and the logger service. And this it will get us to where we want to be. After this, we step back, explain it very well, because this is basically how Nest.js work. So now we have a user service. And in this user service, this has a constructor. This constructor takes in email service and logger service as parameters. So this email this email service is equal to email service, and this logger is equal to logger, like this. Now we want to register a user because this is a user service. Maybe you want to register a user in our company, our application, or anything. Let's say register user. And then we take in the user data. Say maybe the name, the email, and the rest of the credentials. Say this logger. And then we say registering, let's say registering user. Then we do something like user data email, like this. So after registering the user, we need to send them a mail to let them know they are registered and all of that. Maybe a welcome email or something like that. Then we say this email service. That is the email service that sends messages. Then we say send message. So this takes 3 arguments. The email, that is a 2 user data email, and then we say welcome as we did earlier. And we passed in, okay, this one is, we say, let's say, thanks for registering, like this. So after registering a user and saving their data to the database, let's say this logger, let me say it's a service that saves users to databases, and then we send them an email, a welcome email. And after that, we will see after that we say, okay, we want to log another message. See, or this logger log. Okay, so the logger has, okay, now we have logger that has a method of log. Logger has a method of log. Okay, so what we do is we say user registered. We'll come over here, say .log. We registered a user. So after registering a user, just look at what's happening. Can you see how we are efficiently using multiple classes? Now, this service, the user service doesn't even know what the email service is, what the logger service is. But as you can see, we are just registering a user, sending email, and then logging the user as well with these 2 services inside of another service. So you can see when we talk about dependencies, these dependencies, they are being resolved here, are actually the email service and the logger service. The user service depends on the email service and the logger service. So they become the user service dependencies. The user service now has dependencies, 2 dependencies, which are email service and logger service. So let's see how we can go about this. So now that we have that, we have our container. Where is our container again? Our container is way above. So this one here is just a container that we can use to register services, register singletons, and resolve services as well. So let's see, cost container is equal to new di container, like this. So now that we have a di container, so our email service is a singleton actually. And our logger service is also a singleton. The reason why is because we just want to have a single instance of the logger service in our application. And we also want to have a single instance of our email service, because we can just call that from anywhere and send emails because they have the same interface and all of that. But the user service here actually depends on the email service and the logger service. So if you register a user, we can register a user in different places. It depends on how we want to register users. Let's say the user service, we can register a user service actually, but different instances of that user service will be created. So if we register a user with its dependencies, we can use that service we can use different instances of that service in our application, but the email and the logger, we just need a single instance that we can call anywhere and then reuse instead of recreating them every time. So let's say we have our container now. So what do we need to do? We need to register container dot register. Let's register the singleton classes first. Register singleton, which takes the name, which is email service. Remember what register is doing. Register, it's grabbing the name of the service and it's actually using it as a key, and the other properties are being used as the value. So we are storing it now. Registering is just adding it to our storage. So what are we registering? So this will take a callback function that efficiently registers our email service. So we create a single instance of our email service and we register it. We don't want to create it again. So we have container. This time around, it is also registering a singleton, but this one is the logger. Look at how I'm using the names, exactly the names. We have the user service here. So anytime we want to use this, just look at the user service here. We're using the email service and the logger. So that is the names we want to register. We don't want to make mistakes in the spelling here. The logger here, email service. That's what we want to do because we are grabbing them and reusing them. So in here, we also have a callback function. This callback function registers the logger, new logger service. So after doing this, we just have one instance of email service and one instance of logger service because they are singletons. And we've handled that case. Now we want to register a service, an actual service that depends on the email service and the logger service, which is a user service. So we see container register. So now what is the name? The name is user service. And this user service has dependencies. And if you take a look at the register method here, this register method takes in 3 parameters: the name of the service, factory, and dependencies. So let's see how we go about that here. So now that we have the name, factory, and dependencies, what is the factory? The factory is actually an instance of the service itself. So let's say this will take a callback function that will create an instance of that service. So, but the instance we want to create is a user service, but the user service here depends on 2 other services, and the constructor here takes 2 parameters. Where is it? Okay, the constructor here takes the email service and the logger service. So we need this callback here. We take email service and logger, and then it will create an instance of new user service, passing in the email service and logger from this callback function. Remember, you may be wondering, why are we having a user service? And this is the factory. The factory is an instance of that service with all its dependencies. And look at how we are managing the factory here. Look at how the factory is being created. Service config.factory, dependencies, and we are returning the instance. So since we are returning the instance, we will handle that here. This is the instance we are creating and returning. We will create this instance and return it. But in creating this instance, remember, we call the new keyword, we write the new keyword, the service name, and we pass in the argument, which is the email service and the logger service. These are the dependencies. There's the other services that this service depends on. So the next thing is actually the dependencies. What are the dependencies? The dependencies are dependencies is actually an array: email, service, and logger. Now that we've registered the service, we've grabbed the service name, we created an instance of the service, passing in the dependencies, and we've also passed an array of dependencies that the service depends on. So now that we've registered the user service, we'll come over here. We want to resolve it and use it. In order to use it, we must resolve it. So we could say const user service is equal to container resolve, not register, container resolve. And in resolving, we just need the name. And what is the name here? The name is, sorry, not the name, the parameter. This resolve method takes name as a parameter. So we need to pass here the name as an argument. So what is the name? The name is user service. Remember the name here. This is the name. So in order not to have magic strings, you can say const user service name is user service name is equal to user service. And then we come over here. We pass in the user service name like this. And we want them to be exactly, we don't want magic strings. Then we come over here, passing user service name like this. Okay, so now that we've resolved our user service, how are we going to use it? It has just a single method that registers a user. So we see user service register user. Then we pass in the user data, which is the email, john@node.com. Wow. So finally, we've created a container services resolved and we use them. So we say node di container.js. Whoa. Give me a minute, please, a second. Okay, so we've seen how we can create a container. Okay, so should I just zoom out a little bit? Come over here. Pardon my manners. So now we have dependency injection container. So this container registers services and singletons. So when we call the register method, we're actually registering a service. We call the register singleton method, we're actually registering a singleton. Now moving on here, we have the resolve method. So this resolve method is what is actually allowing us to use the services we've registered. So first of all, we have the service configuration, which we get from our storage system in our GI container. So if there is no service, so let's say we want to register a service, we want to resolve a service of, let's turn this to a string like this. Let's run this once more. So identify user service has already been declared. Okay, let me just expand this. User service go to GI container. Okay. I guess this is user service 2. Let's change this to 2. Clear the terminal and run this. Okay, so this time around we have user service name is not found because we are checking for this case as well. So we are trying to register to resolve a service that has not been registered because it's not found. We can't find it in the services. It's not in the storage. So we throw an error. So we throw an error because it's not in the storage. Now moving on, if it's in the storage and it's a singleton, we'll actually return it because it has been created. We don't need to create it again. We just need a single instance. Okay. So if it's not in the storage and it's a singleton or it's a regular service, we'll go ahead and resolve the dependencies. Now, after resolving the dependencies, we'll grab the dependencies and then pass all the dependencies in the factory. So this is an instance, as I'm still repeating this. The factory is an instance of that service with all its dependencies. So as you can see, we are spreading the dependencies here. So it's no longer an array, but let's see if the array is a string of comma separated names of dependencies. That is what we have in this factory. So the instance now is a service factory. The factory is an instance of that service with all the dependencies. So after creating it, if it's a singleton, we will add it to the singletons here. We'll add the instance to the singleton so we can grab it later without creating a new one. Then we'll return the instance. So that is the reason why we have a user service here, because we are returning the instance and then assigning it to this variable user service, this constant user service. So have a container resolve. We just need to pass in the name. So after passing in the name, just passing in the name, we do all of this work, resolving and doing everything, the dependencies and everything. So we return the service and then pass it to this. So first of all, we have to register because we have a service and we don't register it, we cannot use it. So now we're registering a singleton. This is an instance of it. This has no parameters to a constructor. It has no constructor either. But if it has a constructor, the constructor will have some parameters. If it has some parameters, we pass arguments to this callback function that will be passed to that constructor parameters that will represent that constructor parameters. But since there are no parameters to the constructor and there's no constructor, we'll just create an instance of this image service and then store is to register it to add it to the singleton storage so that next time we grab it without creating another instance. But if it's a service, we can come over here, grab this, drop it here. Let's say, for instance, username service 2. Let's just say user service 2. Then add 2 here. Come in here, we change this to 2. Change this one here to 2. Like this. And we have a user service. Where is it? User service 2. Let's leave this as 1 and then change this to user 2 like this. And then we'll come over here and say user service 2 dot register user. Pass in an email of Kent. But with this, you cannot do that. Okay, let's just copy 2 of these. Paste it here once more. And now let's run our function. We have log register user john@doe.com, email sent to John Doe. So user registered. Register another user Kent. So we now have two instances of this. Now we can come over here and even say log new DI container. Yes, use okay. Those services. I just want us to note that we've registered and run that already. Oh, I just want to get hold of this. Okay, so this means we are creating another instance that we've not registered anything. So we just need to log the container, which is the same instance we are dealing with. Sorry about that. We're creating another instance that has nothing in it. So let's run this. Great. So this is what I want us to see. So this DI container has services. It has email service, logger service, user service, and user service too. And you can see here the email service is a singleton. The logger service is also a singleton. But you can see we created this twice. We have email service logger, and what we are seeing here is just each of them is just a single. We have only one of them. Each of them appears once in this storage. We have email service here and we have logger. We cannot see it anywhere else because it's a singleton. And we're handling a case where if it's a singleton, we don't want to create it twice. Then we have the user service here, the first one and the second one. And if in case you want to verify this, we can actually change this back. And now if we check singletons, we have email service, which is the email service, and we have logger, which is a logger. So if you come over here and run this, okay, service name not found. Okay, we have to register it. Register user service name. User service name, like this. So we don't even need to resolve it. Let's comment this one out and then log this to the console. Okay, I'm trying to use that somewhere else again. User service 2. Okay, Kent. Okay, so now we have email service, logger, and user service. So we are not registering it somewhere. Okay, but to cut the long story short, we can only have a single instance of a singleton in our app. Well, apart from that, other instances, other services, we can have more than one instance. So we can change this, and we're going to be having multiple instances of the user service in our application. For the singlet and for the email service and the logger service, we just have a single service. So now we can see how we've created a dependency injection container with services and singleton storages. Now we'll register a service, register a singleton as well. And the difference here is the singleton is false and here is true. They will try to resolve the service and reuse it. So as you can see, this is just a dependency container. It's just like a base class, a base class where we can use to create and manage services. So we'll come over here, we have the email service and we have the logger service. Each of these has single methods. Okay, let's say the email service has 200 methods and the logger service has like 10 methods. Then we want to reuse them inside of the user service. So what we need to do is pass them as pass their instances as parameters to our user service constructor and then initialize them. So after doing that, our user service constructor is only responsible for registering a user. So what we do in here, we'll log the user email, register the user, log the email, send them a welcome message, and log the final message that the user have been registered. So now that we've prepared everything, we just want to use it and see that it's working. So now we've created our dependency injection container. So this container now, we've used this container to register our email service and our logger service. So now we have the user service name, which is user service because we don't have magic strings. The user service name. And this user service name, we want to register it, so we pass in the name. We pass in the instance. So what we can do is we can come over here, see const user service instance is equal to, then we will grab this, bring it over here. Okay. Grab this, bring it over here. So this comma is causing issues. Bring it over here. So this is like a function that is creating an instance, receiving this as parameters, creating an instance and passing these parameters to this class. So now we'll come to this place and we'll call our user service instance. Is it user service? User service instance like this. And this is still the same thing if you are confused. Now, if you go ahead and nope, what's happening? Control. Okay. So if I come over here, clear the terminal and run this once more. Let me even do away with this a container. We're logging this one and this one. So we'll see clearly what's happening. So if you run this once more, we can still see that this runs. So this is basically an implicit way of doing it. You can take it out. This is a callback function. We pass in the parameter of email service and logger. Then we do this, create this service. This is an instance to this service, but the only difference is we are lazily creating this instance, as you can see. And the reason why we are creating these ones, if you hover over this singleton, you can see that the dependencies is optional because we have a default parameter of an empty array. And that is the reason why we can actually come over here and pass in an empty array, and we're still good to go. If you want to explicitly do that, we can just do that and you are still good to go. So if you clear our terminal and run this once more, we still have the same result. But the reason why we are not passing an empty array because we already have a default parameter of an empty array. And if the argument is undefined, the empty array will be assigned to the argument of dependencies. So it will resolve to an empty array, no dependencies. This service doesn't have any dependencies. But if it has dependencies, we pass in this array here, pass in the dependencies, and pass in a parameter of those, an argument, a parameter of those dependencies to this callback function. And then it will forward them to this as arguments to this email service here. So that is basically that. Wow, this is much, much, much. And some of us are already confused. But you just need to take your time, go over this thing. First of all, understand what a service is, what a dependency injection container is, what the register method is doing, what the resolve method is doing, and understand what a singleton is. You can note this down or you can take note of the slides. You also need to understand what the factory is. And it boils down to the map. Okay, so that is basically it. So if you come over here to our reg.js, remove this. See, once names is equal to new map. See, names dot set name.set John. Say email is John and the name is John. The email should be John something. Let's say John at do.com, like this. So copy this. I will say Kent. Kent at Kode, Kent at Kode.com. Let me say the name here is Kent, like this. So what we do is, let's first of all log names. It's not actually names. This is these are people. So we should have called it people, but let's leave it this way. You say node rec JS. So as you can see, this John here maps to this one, and this Kent maps to this. This is the reason why it's called a map. And you can set the name, the key to be anything. You can even say the key should be JSON stringify an object of email sum and name sum. Now, if you come over here and do this, as you can see, the key, look at the key. Now we can try to remove, and the key to a map can be anything. It's not like objects that it can only be strings. It's not like that in maps. The key to maps can be anything. As you can see, the key here is this, and it's pointing to this. The key here is image sum and name sum. But if you come over here, and then you try to see log names get, copy this, paste it here. And then we run this. Okay. Then we have undefined. Okay, so can anyone tell me the reason why we have this key, the same thing with this one, and we're having undefined here? It means it cannot find this key. There's no value attached to this key in this map. So it means the key doesn't have any value. It does not find it in the map. So does anyone have any idea the reason why it's like that? Because this is the same thing. We have image sum and name sum. So why are we seeing undefined here instead of seeing the value here, which is John at do.com and John?
Okay,
Okay,
maybe
so in order to
object.
explain that, we don't even need to talk too much. Let's say log this is equal to this. Oops. This, like this. So let's say, let's add something that will make us, let's say, comp, like this. So let's run this and see. And we are seeing false because we have, these are reference types. And the first object is not the same as we have two objects in memory, the first one and the second one. They are two different objects that are not even close to being the same. They're not the same at all. They are two different objects. So if you set this as a key, the only way you can make this happen is come over here and say const obj key is equal to, okay, this. Then remove the comma. And instead of doing this, you say obj key. And here you see obj key. And now we have our value. Then if you say obj, where are we checking the obj key? Then you say obj key. Nope. Obj key. Let's run this once more and see what we've got. So now we have true, because this is a reference type, and this, you are assigning this reference type to this constant object. So it holds this reference in memory. So it's pointing to this reference type. So anywhere where you log this, you still have this, because this constant is pointing to this reference type and it's not being changed. So that's the reason why I say it's exactly equal to it, yes. But if you create the same thing like this in two places, you are creating two different objects. That was the reason why we did not, we received undefined, and this compare returned false. So now the map can use any key, as a map. So let's do away with this. And we can even say the key here is name. Oh, okay, so John. So try to avoid duplicates in why writing code. It's very important to always avoid magic strings and magic numbers. So now that we have our key, we're using the key here and using the key here. And we run this, we have our value, John. So we can even check, we can see after setting this, we see, we can say names dot has obj key as our last option here. And it will return true because it actually has that. But if you change this to, let's see, Kent. Okay, Kent is in the, let's say KL. Name dot has this map. Does it have map has this key? There's no key like that, because we're using this key to grab the value from the map, because the key maps to the value, but it's saying false because there's nothing like that. So if you want to check, maybe if you say if names dot has obj key, then what we do is we say log names dot get obj key, like this. So now if you just run this to get john@dole.com, the first one and the second one. So if you have if you pass something different, like some, and you run this, you have just this one. Let's remove this and run it once more. We have nothing, because this doesn't, it returns false, and this block doesn't execute. But if you pass in something that exists, obj key, you run it, and then you have this. So we've taken this time to learn something useful. Objects and arrays are reference types. So if you create two arrays, if you say const array 1, and you see another one const array 2, these are two different arrays, very two different ones. This is not, never and not equal to this one. So that basically it's, we've built a simple DI container and use it to register services and also make it work. Okay, so moving on is testing DI applications. So why is testing DI applications easier? Okay, so a second, please. Okay, so why DI makes testing easier? So dependency injection makes testing much easier because one, easy mocking. You can inject mock implementations. Two is isolation. Test one component at a time. You isolate all the components from each, or you test one component at a time. Then predictability. You control all external dependencies. So if you want to mock them or anything you want to do, well, they are predictable, so you can control them. Speed. You don't know no need for real databases or APIs. All you need is to mock the dependencies and mock the services. So mocking is a kind of an it's a basic concept in testing, but it's way more advanced. So we'll talk about that in our subsequent classes, and not this one. So we're going to be learning how to test DI applications. Just a basic, we just write a basic setup and see how we can test it. We just use the built-in testing methods and all of that. So create a new function of testing JS. And inside of this function, inside of this file, sorry, not a function, we call mock email service, which takes instructor. And this constructor initializes emails to this sent emails is equal to an empty array. Those the emails that we've already sent. So this is a mock email service. We can use this for testing. And if you don't understand mocks, don't worry. We'll talk about all of this in our subsequent classes. All you need to know now is just focus on what you're learning for now. But later on, we'll talk about that. Then we have send that, oops, what is this? Outside of the class? No, should be inside. So we have the send method that takes to body and subject. And inside of this, we say, okay, this send emails. Since it's an array, let's say push, then we push in an object of to body and subject like this. So anytime we send an email, we add it to the sent emails array because we've already sent it. Then we have another method of get sent emails. So this one here returns these sent emails. We want to return the emails that we've sent. Okay, so another method, which is a clear, called a clear method to actually these sent emails is equal to an empty array. Now we also mock our logger. So we'll see, let's mock logger. Oops. Mock logger. That this also has a constructor with no parameters. And in this constructor, say this logs is equal to an empty array. Then it has another method of log. This one takes message as a parameter and logs. Okay, no, it doesn't log. see, I guess we should do the same thing that we're doing here. Just push it to the logs. Since we just want to test, this dot logs push message. Oh, what's this? Okay. Message. Then we rename this one here to message as well. Okay, those are two methods. So we can get the logs and we can clear the logs as well. So let's copy this, bring it here. Get logs, clear the logs. Logs like this. Okay, so we have two classes here. One for mock email service and the other one for mock logger. So the next thing we have is a function that tests user registration. So we have function. So just take these two mock classes to be something we are doing here, something we've implemented here. Just take it to be the email service and the logger service, but we don't want the implementation details. Testing is actually making your app work the same way the users will interact with it. So what we want to do here is we want to make it work the same way if users interact with how it will work. So we say test user registration. Which we say const mock email, which is equal to new mock email service in const mock logger is equal to new mock logger like this. And also, okay, so let me just quickly grab our email service here. And paste it in our testing.js instead of writing it over again like this. So let's make sure that the logger here, so log user message, email service editor welcome. So this is the message. Okay. This is the body and this is the subject. So let's check body, subject. Okay. So now we have our user, but then we say we want to test our user service. So we're not mocking it. We're actually testing our user service. Say const user service is equal to new user service, like so. And we test it with data. We say const user data is equal to email john@do.com and name should be John, like so. So how do we test this? Okay, I guess I just copy this and bring it in here. I don't want to rewrite everything. Let me just remove this. Paste this down. So I recopied. So copy this, paste it in here below. So that we don't want to keep copying and copying. So what we want to say is well, we're creating the user service twice, which will cause a problem. Let's just remove this one here. Okay, so what we want to do is we want to test. So we'll say user service register user. And the register user takes in user data, like so. So we want to register a user. So we'll say, okay, what do we get? The sent emails const sent emails is equal to mock email that get sent emails like this. And now it's time for the actual testing. So we'll come over here and say const console assert. Then we say sent emails dot length, and we want to check if it's exactly equal to 1, because we've registered the user. We've registered the user here. So it will send one email. Once you register a user, an email is sent. So we see what is the message. You see should send one email. Okay, let's run NodeDI. Log, this logs push. Okay. Okay, so the error is way back in our logger that doesn't have, okay, it has a log. Log. Okay. Can you still see my screen?
No, we cannot see us.
Okay. So I guess the network interrupted.
It's back up.
Yeah. So now there it's 64. So let's check 64. This logger log register user service. The logger here. This logger.log. User service register user logger log. So, but we have a log function here. So let's check the mock. In the mock classes, we have logs and we also have log. This log, this has log, push this. Okay, so why are we getting this error? Properties of undefined reading log. Return this dot logs. This was log push. Okay, so this debugging here, it's getting okay, you know what? Let me just comment the log, comment this one, see what we've got. Error again. Mail service sent. Okay, so I guess it's an error somewhere actually. Register user, email service logger. Okay, so when we call this email service, we did not pass in the email service and the mock logger as dependencies. So that is the reason why we're getting that error, I guess. So let's try again and see. So the error, email service is not defined. Mock email. I'm just making a lot of mistakes here. Mock email. Another error. this sent emails is not defined. Wow. 105. So we're just getting a whole lot of errors here. This dot sent emails. This sent emails. Okay. Mock email. Mock logger. User service. So sent emails. Mock email dot get sent emails after registering a user. Okay. So let's okay. Sent emails is not defined. Okay, JavaScript with its problem. So we're getting a whole lot of errors. And I don't seem to know why. Okay. Sent emails dot length is equal to 1. Mockers get sent emails. Get sent emails actually returns the emails here. Get sent emails. I say it's not defined because we have the new email service, the new mock logo. Okay, so let's just do few things and see what's going on. Let's log some things to the console. So mock email, mock logger, user service. So let's grab this one here, bring it up here. After registering the user, we want to log it and see what we've got. Okay, so the mock logger here is register user, user registered, logs. The email service sent emails, sent objects, this. Sent emails. We have one here. We've sent it and we've added it. The users, the mock logger, we've got the logs here. We have 2 logs, register user with John Doe and user registered, because that is what we are doing. This is what this service is doing. After registering a user, where is it the class? User service. Register user John Doe and user registered at the end. Then we've also sent an email. So that's the reason why we're seeing this here. But then, why are we getting undefined? Console mock emails. Okay, let's cut this one, bring it to the top, comment, and log it as well. Sent emails. Okay. So return this, the sent emails. Wow. We're out of time. I guess sent emails, mock email dot get sent emails. So it's supposed to return the array. And here it's saying these are sent emails. It's not a function. Oh, okay. These are sent emails. So why am I calling it as a function here? I just want us to rush and service get sent emails. These dot sent emails return 105. Okay, this is an array and not a function. Here is a mistake. Array and not a function. Let's try this once more. Okay, so now it's working and we can see. So let's come over here and uncomment this one. So clear the terminal, run this once more. Okay, let's remove this one here. Run this, clear. Console.assert. Okay. So what's wrong again? We are out of time. Console.assert. Send image.length is equal to 1. Output. We're supposed to just checking to see if. Okay, so we can just change this to console.log and just see something. Okay, so this is true. Send image or length is 1 and should send 1 email. So our test is working. As you can see, we've mocked the logger and we've mocked the email service. So this is not the correct implementation, but we've mocked it and we've seen that, okay, so our user service is working. What we are testing is not the mock logger. It's not the email service or the logger service. What we are testing is the user service, but it has other dependencies, which is the mock email and the mock logger. So all we need to do is to mock them and then pass them as dependencies. So we've mocked them and now they are working as expected and our test is actually passing. So we are out of time, and if you have any questions, you can go ahead and ask.